This is the solutions to test 2 that you had last Friday, or actually it was last Thursday. For 1 through 5, find the missing terms in each arithmetic sequence. These are problems 23 through 27 on page 63 that we did in class. You should probably look at your notebook. And if your notebook was halfway organized, you could simply find those problems on that date back in section 2.1. Okay, so how did we do these? Let's see, there's a difference there. There's a difference there. There's 2 differences. The total difference was 60, so 1 difference had to be 30. So once you calculate the difference, you can simply add that. 10 plus 30 is 40, and 40 plus 30 is 70. Remember, it does have to be an arithmetic sequence, so you're adding the same amount to each term, and that works fine. So 10, 40, 70. Okay, for the second one, sort of the same reasoning. You have a difference there, a difference there, and a difference there. There's 3 differences. Again, the total difference is 60. So the difference for this one is 20. So once we have that, we can simply add 20 to each term. We add 20 to 10, and we get 30. We add 20 to 30, we get 50. We add 20 to 50, we get 70. Okay. Likewise, for the next one, there are 4 differences. Right? That's a difference, that's a difference, that's a difference, and that's a difference. 4 differences. The total difference is, again, 60, right? 70 minus 10. So in this case, the difference is 15. Once you have that, you just add 15 to each number to get to the next number. 10 plus 15 is 25. 25 plus 15 is 40. 40 plus 15 is 55. And just as a double check, 55 plus 15 is 70. We're good. Okay, these get old after a while. There's 1, 2, 3, 4. There's 5 differences. 5 differences. Again, the difference is 60, right? 70 minus 10 is 60. So each difference is 12, right? 60 divided by 5 is 12. So we just add 12 to each one, and we should be good. So 10 plus 12 is 22, plus another 12 is 34, plus another 12 is 46, plus another 12 is 58, plus another 12 is 70. Okay, and for the last one, there's 6 differences. Each difference is 10. So 20, 30, 40, 50, 60. Okay, so pretty straightforward problems for 1 through 5. Okay, this was actually just copied right out of the book. So inductive reasoning can be used to find patterns, to find the 100th term of the arithmetic sequence 2, 5, 8, 11, 14 is difficult if you don't know a shortcut. The first term is 2, common difference is 3. The shortcut can be found by using inductive reasoning and the following pattern. Okay, so note the first term, there's a 0 there. For the second term, there's a 1 there. For the third term, there's a 2 there. For the fourth term, there's a 3 there. For the fifth term, there's a 4 there. So the 100th term, you put a 99 there. The formula for this one, T sub n, T sub n, whichever term you're looking for, it always seems to be 2 plus 3 times n minus 1. Okay, and that's the formula or the shortcut for this particular sequence. Okay, so once you have that, then depending which test you had, I gave you a problem to apply it. So here's another sequence. Some of you had a sequence that went 8, 15, 22, 29. Some other folks had the sequence that went 7, 15, 23, 31. So again, depending which version of the test you had one or the other of these 2 problems. Let's do this one first, starting with 8. Find the 11th term using a shortcut, T sub 11. Again, just sort of notice the pattern. This is 4, this is 3. So it's always going to be 8 plus 7 times one number less than the term you're looking for. If you're looking for the 11th term, you put a 10 here, so that's 78, right? Multiply, that's 70, and then add the 8, and you get 78. The 101st term, T sub 101 would be 8 plus 7 times 100, so 708. So that was problem 6 and 7. If you had the other version of the test, very similar type of thing. You're looking for T sub 11 here, T sub 11. And again, just sort of notice the pattern. This is the shortcut that you're using. It's going to be 7 plus 8 times 1 less. If you're looking for the 4th term, you put a 3 here. If you're looking for the 11th term, you put a 10 there. So that would be 87. And T sub 101 is 7 plus 8 times 1 less than 101 is 100. So that's 807. Okay. This is a problem where you're asked to find the 4th term, right, T sub 4, of an arithmetic sequence. You do know the first term is 2, and you know the 2nd term is 6. You don't know the 3rd term, and you're looking for the 4th term. That's what this is right here. So how would I do this? First, I would find the difference. So the difference is 4, and then we know we have to add 4. So this is 6 plus 4, which is 10, and then we have to add 4 to that, which is 14. So 14 is the answer. You're adding 4 each time. Okay, so I needed, other than simply 14, I needed to see something that showed how you got it. Okay, here's the geometric sequence. T is equal to 4, and T1 is 4, and T2 is 12. We don't know the 3rd one, and we're looking for the 4th term again, right, 4th term. So for geometric sequences, you need the ratio. Let's see, the ratio is going to be 12 divided by 4, which is 3. So to do that, you just multiply by 3. Right? 4 times 3 is 12. 12 times 3 is going to be 36. And 36 times 3 is 108. Okay, 108. And that's it. Okay, so that's 8 and 9. And again, check your version of the test. The sequence of squares, there is one sequence of squares. It goes 1, 4, 9, 16, 25, 36, 49, right, 64, 7 times, 8 times 8, 7, 8 times 8, 9 times 9 is 81, 100, 121, and so forth. That is the sequence of squares. Now, suppose you had a sequence of squares where you start with 81. So now we're starting right here. This is T sub 1, this is T sub 2, this is T sub 3, right? And your task is to find T sub 4, the next square. So T sub 4 is going to be 144. It's 12 squared. Okay, so basically you're deleting all of these and just starting with 81. Okay. Fibonacci sequence starts 1, 1. Now remember how these are generated. You add 1 and 1 together. You add 1 and 2 together. Add 2 and 3 together. 3 and 5 is 8. 8 and 5 is 13. 8 and 13 is 21. 13 and 21 is 34. 21 and 34 is 55. 55 and 34 is 89. 89 and 55 is 144. Okay. So that is the Fibonacci sequence. Starts with 1, 1. Suppose you have a sequence that starts with 8. So this is T sub 1, and T sub 2 is 13, T sub 2. So we were basically chopping these off, looking at T sub 1, T sub 2, here's T sub 3, and that would be T sub 4, right, the 4th term. This is the 3rd term. Oh, there you are, the answer is 34. Follow directions. Each sequence tell whether the sequence is arithmetic, geometric, or neither. If the sequence is arithmetic, give a common difference. If it's geometric, give the common ratio. And again, you should be looking in your notes, pages 67 or 69 and 70, problems 14 through 21 were the exact same problems in the exact same order. So let's see. Let's check for arithmetic first. A common difference of 5, another common difference of 5, a common difference of 5, and a common difference of 5. So this is arithmetic, arithmetic, and the difference is 5. Okay, so let's try this one. Again, we'll check for arithmetic. The difference is 6. That difference is not 6. So we know it's not arithmetic. Maybe it's geometric. For geometric, we're looking for ratios. 8 divided by 2 is 4. 32 divided by 8 is 4. Now, as we get into larger and larger numbers, you can use your calculator. I don't have any problem with that. These are not terribly hard arithmetic problems, but the calculator makes it easier. 128 divided by 32, yeah, that's 4. And 512 divided by 128, 512 divided by 128 is, again, 4. Okay, so sure enough, this is geometric. And the ratio is 4. Okay. Number 14. Again, let's check arithmetic first. The difference here is 2. The difference here is 3. So not arithmetic. There's not a common difference. So scratch that. Let's try geometric. If we divide 3 by 1, we get 3. If we divide 6 by 3, we get 2. So there's no common ratio either. This is one that's neither. Now, it is a nice sequence. Obviously, you know, you could tell what's happening here. These are the triangular numbers, if you remember. You started with 1, and then you have 3, and then you have 6. These form triangles, right? Then you have 10, so put 4 more in there. And then you have 15. So there's a very nice pattern there, but it's not arithmetic and it's not geometric. So just follow the directions, right? This is neither. Okay, number 15. Again, same direction. So let's just double check and see if we can figure out what's going on here. So there's obviously not a common difference. 40 minus 80 is negative 40. 20 minus 40 is negative 20. 10 minus 20 is negative 10. So no common difference, not arithmetic. Let's try geometric. So for geometric, we have to divide 40 divided by 80. Well, that's a half. And 20 divided by 40, that's also a half. And 10 divided by 20, that's also a half. And 5 divided by 10, that's also a half. So this is geometric, and the ratio is a half. Okay. What's going on with this guy? Let's check arithmetic. The difference here is 17. The difference here is 17. The difference here is 17. And the difference here is 17. So this is arithmetic, and arithmetic with a common difference of 17. And again, I don't, you know, you could do these subtraction problems on your calculator. I don't have any problem with that. So 71 minus 54, right? 71 minus 54, sure enough, or 54 minus 37, still 17, or 37 minus 20, or 20 minus 3. Okay, so common difference. Okay, what's going on here? These are growing pretty rapidly, so probably geometric. Let's check. 6 divided by 2 is 3. 24 divided by 6. Well, that's not 3. That's 4, right? That's 4. So not geometric, does not have a common ratio. And again, feel free to use your calculator. I have no trouble doing this if you want. 6 divided by 3, or 6 divided by 2 is 3, but 24 divided by 6 is not 3, it's 4. And if you did 120 divided by 4, or divided by 24, sorry, divided by 24, you get 5. So, I mean, the ratio, there's a very nice pattern to the ratios, and this happens to be 6. But it's not a common ratio, so this is neither. A nice pattern, it's easy to figure out what's going next, but not geometric or arithmetic. In fact, these are the factorials. So the people that did the gene washing problem. A lot of you did that. You probably recognize the factorials, right? This was 2 factorial and 3 factorial and 4 factorial, 5 factorial, 6 factorial, and so forth. Okay, but again, just follow the directions. Okay, 18 and 19 again, same directions. We're checking to see whether or not these guys are arithmetic or geometric. So the first thing we do is we check for differences. See, 51 minus 60 is -9. 42 minus 51 is -9. 33 minus 42 is -9. 24 minus 33 is -9. And again, no problem using your calculator. If you don't like the negatives, you can still do that here very nicely. Remember, we're subtracting 51 minus 60, sure enough. And then 42 minus 51, sure enough. 33 minus 42, sure enough. 24 minus 33. Okay, so common difference. This is arithmetic. And the common difference is -9. Okay, and the last one, again, we can check for differences. This difference is 16. And again, if you don't want to do that in your head, you could do it over here, 48. Take away 32, sure enough, and then try 72, take away 48. Okay, so not a common difference, right? Not arithmetic. Let's try ratios. So for ratios, we're dividing, right? So to find the ratio, you take 48 and divide it by 32, and that's 1.5. And then you have 72 divided by 48. Oh, that's also 1.5. 108 divided by 72 is also 1.5. And the last one is 162. 162 divided by 108 is 1.5. Okay, so here we do have a geometric sequence, and the ratio is 1.5. Right? Okay, grains of rice on a chessboard, binary sequence. How many grains were placed on the last square of the first row? There are 8 squares on the first row. So let me just draw a little sketch here. We need, let's see, 1, 2, 3, 4, 5, 6, 7. Okay, so there was 1 grain here. 2, 4, 8. Remember, we're doubling. 16, 32, 64, 128 there. Okay, so answer 128. No, you didn't have to do, 32 grains here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. That would be a little silly. Just write the number. Okay, number 21, being paid a penny to cut the grass, doubling the amount each day. How much money was paid on the last day of the second week? Okay, so now we have our calendar here. And there are 7 days in a week. Okay, so these are the Sundays, Mondays, Tuesdays, Wednesdays, the Thursdays, the Fridays, and the Saturday. So we'll do pennies again. That's 1 penny, 2 pennies, 4, 8, 16, 32, 64, $1.28, right? 2, 56, 5, 12, $10.24, $20.48, $40.96. And again, you could double these on your calculator if you want. So let me just take 40, 96 times 2. Okay, so $81.92. 81.92. That's how much money you got paid on the last day of the second week. So some sort of diagram like that makes it easy to do. Okay. This was one that we did in class, and again, you can just look at your notes. Continue to the 15th term. Okay, so we're adding, right? So we need T sub 9, t sub 10, t sub 11, t sub 12, t sub 13, t sub 14, and t sub 15. And we're adding these guys together to get to the next term. So 34, 55. Okay, and again, you can be adding here, so I don't have any problem with that. This is what, 89. Use your calculator if you have to. Let me make this a little bit smaller so I can see it. 55 plus 89, there's 144, that's gross. 144 plus 89, 233, 233, 233 plus 144 is 377, and 377 plus 233 is 610. 610. Okay, so there's the list to the 15th term done. The terms of the sequence that are even numbers form a pattern. The pattern has to do with their position in the sequence. What is the pattern? So somehow to do with the position. Let's find the even numbers. Okay, so that one's an even number. That one's an even number. That's an even number. That's an even number. Remember, even numbers end in 2, 4, 6, 8 or 0. Okay, so it looks like every third Fibonacci number is even. Okay, the terms that are evenly divisible by 5 form a similar pattern. What is that? Okay, so numbers that are divisible by 5 either end in 5 or 0. So every fifth number, every fifth Fibonacci number is divisible by 5. Okay. Complete the following pattern. So here we're just adding the numbers up. This adds up to 4. This adds up to, let's see, we have 3, 6, 7, 8, 9. So we're adding up. There's 3, 6, 10, 16. Oh, wow, these look like to be squares. 1, 2, 3, 4, 5, 4, 3, 2, 1, 25. What sequence do the numbers in the right column of the pattern form? These are the sequence of squares. Remember, those were the triangular numbers. Adding triangular numbers gives you squares. Okay, and that was it. The last problem was specific to your project, and shame on you if you didn't do well on those. They're very similar to the project problems. Okay, let me stop this here. You should be reviewing this. Remember, we do have a final exam. We have a semester exam right before Christmas, and the semester exam questions come out of the tests. So make sure you save your tests and know how to do all these problems.